So hey guys, welcome back to another lecture. In a previous lecture, we have discussed something known as composite functions and a parabola. So I have given a work like research about the parabola, and so I hope you've done the research. So today I'm going to cover trigonometry. So what do you mean by trigonometry? So the trigonometry is just a branch of mathematics that deals with the relations of the sides and the angles of the triangles. As a simple like it's just a study of triangles. Okay, it's just study of triangles. So especially it's a right angle triangle, especially in a right angle triangle, right? So there are three main trigonometric functions. So what are they? There are three main. So what are they? They are sine, cosine and the tangent. So what is sine and what is cosine and what is tangent? This is your work. This is your work to research about it. So it's just a fancy names for the angles, right? So we have a sine, we have a cosine, and we have a tangent, right? So we are having three, and we have a three reciprocals of it. We have a three reciprocals, so we have a reciprocal of these three trig functions. So what are they? The sine will become cosecant, so the sine will become cosecant, and the cosine will become secant, and the tangent will become cotangent. I hope you're getting it. So these are called as a reciprocals. These are called as a reciprocals. Okay. So what is this SOHCAHTOA? What is this? This is called as a SOHCAHTOA. SOHCAHTOA. So what is SOHCAHTOA? You're going to get down here. So for example, we have taken a right angle triangle here. We have taken a right angle triangle here. So this is the hypothesis. This is the opposite side, and we have a adjacent side here. So we going to find the theta here. So we going to from here, from point B, here the theta degrees. So the what is H? Hypothesis, and the O, which is the opposite side, and the A, which is adjacent side. I hope you're getting it. So what is H? H is the hypothesis, O is opposite, and A is adjacent. We have a right angle triangle here, so it is 90 here, it is 45 degrees here, and this is 45 degrees here, which is total 180, right? Which is total 180. So from the SOHCAHTOA, what is SOHCAHTOA? What is SOHCAHTOA? So it's just a kind of a formula to remember the sine, cos, and the tangent. So I'm going to give that. So what is the sine? So I'm going to find the value of sine here. So what is this sine theta here? So what is this sine theta here? So the sine theta. So we have a right? So the sine theta is opposite side by h. So O by h. The sine theta is O by h. So what is O? Opposite side. And what is h? Hypothesis. So we have the sine theta is equal to the opposite side by hypothesis side. I hope you're getting it. So what is the sine theta? The sine theta is opposite side by hypothesis side. This is equal to O by h, which is here. So the sine theta is opposite side by hypothesis side. So what is the cos theta? What is this cos? So the cos theta is A. What is A? Adjacent side. And what is H? Hypothesis side, right? So the adjacent side by the hypothesis side. Adjacent side by the hypothesis side. I hope you're getting it. So the cos theta is, so what is the cos theta? The cos theta is adjacent side by the hypothesis side. Adjacent side by the hypothesis. So which is means like A by H. Which is A by H. Right? So we have another one which have a tan theta. So what do you mean by a tan theta? We have a T O A. What is A? What is O? O is the opposite side. And what is A? A is the adjacent side, right? So opposite side by the adjacent side. Opposite side by the adjacent side, which is nothing but O by A. I hope you're getting it. So we have seen the sine theta, cos theta, and the tan theta, right? So we have discussed the reciprocals also. What is the cosecant, secant, and cotangent, right? So we can find the reciprocals also. So we can write the reciprocals of this triangle of sine and cos and tan. I just want you to stop this video, and I wanted to do it by your own. I hope you do that. So come back to the lecture. I hope you do that. So what is the reciprocals? So we just simply like So as we discussed, right, so the cosecant is equal to 1 by sine theta, right? So the cosecant equal to 1 by sine theta. So what is the sine theta? What is the sine theta? The sine theta is O by H. The sine theta is O by H. If it is 1 by O by H, 1 is O by H, it will become, if it comes to up here, if it comes to up here, then it will by H divided by O. H divided by O, which is hypothesis by opposite side, right? Which is completely opposite of the sine theta. What is the secant? 1 by cos theta. What is the secant? 1 by cos theta, which is simply as a hypothesis by adjacent side. So what is cotangent? Just simply opposite with reciprocal of, which is reciprocal of tan theta. So what is the tan theta value? Opposite side by adjacent, right? Opposite side by adjacent. If it reciprocal, then it will become reverse. A divided by O, which is adjacent side by the opposite side. So I hope you have a better intuition about these, what is the sine theta and how we find that. So I just wanted to give a brief explanation about the thetas. So we are taking the sine theta, cos theta, right? So what are these thetas? So there are two kind of triangles over here. We have two kind of triangles. So I'm going to discuss the what are the triangles we're going to discuss. So we have the 45, 45 and 90, which is a right angle triangle, here, 45, here 45, which is 90, which is total is equal to 180, right? So which is total is equal to 180. The angle is 180. So 45 plus 45 plus 90, it is equal to 180, right? So we have another, right? So this is a 2, right? This is 2, right? We have one here. So and we have a 30 plus 60 into 90. This is right angle triangle. This is also right angle triangle. But here the angles are changed, right? The angles are changed. This is also equal to 180, but the angles are changed from like 45 to 30 60. If it is 45, then it will be like this, and if it's 30, then it will look like this. I hope you having a good idea. Okay, so here we find any function value with the help of these thetas and the angles between them. So the theta is just a angle between the two sides. Okay, so just a angle between the two sides. What is the angle between? It may be a 45, it may be 30, it may be 60, whatever it may be. So it finds the angle between them by using these sine, cosecant, secant, tan, etc. So here are the two right angle triangles as we discussed. So I'm going to give the first example. So first right angle triangle, which we have a 45 degrees over here, 45 degrees over here, we have a 90 degrees over here. So the 45, 45, 90 right angle triangle here. So I'm gonna take two values, 1 and 2. So and I'm going to have a hypothesis of root 2, which is, we have a formula Pythagoras theorem, right? 1 plus 2 and root over here, which is h square is equal to opposite square by h square, right? If we square that value, 1 plus 1, 1 square plus 1 square is equal to 1 plus 1, it will become 2, and h square is equal to 2. If we remove the square, it will become root, and it will become root 2, right? So the root 2 value here. So we just simply plug in these two, we just simply plug in the values here. So I'm going to find the sine value here. So I'm going to write this is a formula, right? So I'm going to write this. So you have a better understanding how we calculate this. So what is this sine? So how we find opposite side by hypothesis? What is opposite side? Here it is 1. What is hypothesis? Root 2. 1 over root 2. 1 over root 2. So if we cannot have a root in the downside, so we just simply, if we do the multiplication with the root 2 and root 2, and then the root get cancelled, and we simply have a 2 value over here, and we have a root 2 over there, and it is approximately equal to 0.71. I hope you getting it. So we have a, and after that, after completing the sine, we have a cos. So the what is cos? Adjacent side by the hypothesis. So what is the adjacent side here? 1. And what is the hypothesis? Root 2. So 1 over root 2. 1 over root 2. So what is the value of 1 over root 2? So we just simply as same as this. So So we just simply multiply with the root 2 into root 2, and then we get the root 2 by 2, and which is approximately equal to the 0.71. So after that we have a tan. What is tan? Tan is equal to opposite side by the adjacent side. So what is the opposite side? 1. What is adjacent side? 1. 1 over 1. What is 1 over 1? It is equal to 1, right? So after that we completed a 3. So I just want to find the reciprocals also. So what are these reciprocals? Like the cosecant. What is cosecant? It's just a 1 by, it's just 1 by 1 by root 2, right? So if it come down here, then it will become root 2 by 1. So the root 2 by 1, which is equal to root 2, and the value is 1.45. So what is the secant of 45? The secant is also same like root 2 by 1, then it will become root 2 and approximately equal to 1.45, the same. So what is cotangent here? Cotangent is 1 by 1 by 1. If it comes here, then 1 by 1, that is equal to 1, same as tangent, right? So we are getting almost the same values, just change here, but we are getting almost same values. I hope you're getting this. So we find here, so we find at point B. I just want you to find the point A and point C here. So I just want you to find like it will become like this, and this will become the opposite side, and this will become the adjacent side. So the same formula follows here. The hypothesis won't change. This is opposite side and this is adjacent side, right? So we just opposite side by adjacent side, so means like opposite side by the hypothesis side, which is 1 over root 2. If it is 2, then 2 over root 2, etc. It depends upon the values of, we have a triangle right here. So I hope you do that with A and with C. So try out from the point A and the point C. So after that we have a 30 and 60 right angle triangle. That it is 30 and this is 60 and this is a 90 triangle. So this is a, so let me write this. So what is this? This is a 30, 60 and 90 right angle triangle, right? So we just simply take 1 2 values, and we have a root 3 over here. We just simply take these values. What is the value of root 3? It is 1.734 and kind of etc. Just ignore that 1.734. Okay, so how we find the values? The same as follows, like same as follows from the Sokotova formula. So same as follows. I write these here so that it is easy to, have a look. It is easy to explain from here. So the what is sine? Opposite side by hypothesis, right? So what is opposite side here? 1. And what is hypothesis here? 2. So 1 over 2, which is 0.5. What is cos here? So cos is a by h. What is adjacent side by the hypothesis? What is adjacent here? Root 3 and hypothesis is 2. So root 3 by 2 approximately equal to 0.86 here. So after that we have a tan. So what is tan here? So what is tan? Opposite side by the adjacent side, right? So what is the opposite side? 1. What is adjacent side? Root 3. So 1 over root 3, which is approximately equal to almost 1. I hope you're getting it. So we just find these values, and I just want to find the reciprocals of it. So what are the reciprocals? Cosecant. So what is cosecant? Which is a 1 by sine, right? 1 by sine. So 1 by 1 by 2. Then it will become like this, and 2 by 1, and the value is 2. Right? So what is the secant? Secant means like 1 by root 3 by 2. Then that will become 2 by root 3. And that is approximately equal to 1.15. Here. So after that we have a cotangent. So what is cotangent? 1 by tan, right? So 1 by tan. What is 1 by tan here? 1 by root 3 by, so 1 by 1 by root 3. It will become root 3 by 1, which is root 3, and the value of root 3 here is 1.73. So we just simply write this value. So I hope you have a basic understanding of these trigonometry. I just a basic introduction to this. So I just recapitulate what I have said. Like, so what is trigonometry? It's just a study of triangles, especially in right angle triangles. So there are three trig functions. What is sine and cos, sine and the tangent. We just simply do the reciprocals of it, and we get our we get our cosecant, secant and tangent. So I have explained the what is the Sakatova and how we find the sine and the cos and the tan values from that. We have taken the two examples here. So first of all, we have taken the triangle with here and how we find the values of sine theta, cos theta and the tan theta, and after that we find the reciprocals of it. And then we have a two kind of triangles, two special triangles, which is 45 45 90, and we have a 30 60 90 triangle. So I just gave the two examples over here. So this is a 45 45 90 degrees, and we have find all the values, and we have a 30 30 30 69 values, and we simply find all the values. So I hope you have a basic understanding of all these. So don't worry if you don't get it, so don't worry, please watch it again. So please watch it again. So don't worry if you get these what is I don't know how to find the root 3 value, I don't know how to find these 2 by root 3 value. So don't worry bro, don't worry. So we don't worry, because we not do by manually, we do with the computers, with the help of the computers and a beautiful libraries over there. So it is easy to do that. So we just simply type the root 3 value, and the computer give the computer gonna give the answer. Why to waste our time and our time and hard work finding these values? So that's my concern about this unit circles. So what do you mean by a unit circle? So unit circle which a unit radius, that is the radius is 1, means the radius, the radius of the circle which is 1, frequently used in a trigonometry. So I am going to give an example. You're going to get a good idea about what is unit circle. So the unit circle of radius 1 and the center of origin. So if we have an origin like this is the origin, right? So this is 0 comma 0. So the center at the origin in the Cartesian coordinate system in a Euclidean plane. So what is Euclidean plane? So I'm going to give an example like what is Euclidean plane. Means like the plane look like this. So this a flat of kind of a flat online, like just such online. I can't explain here. I'm not a good at drawing, so that I just want you to have a explore it on own. Just Google it, you're going to get a good example over here. So like, so it is a, so why the Euclidean name came like? So you may ask like why the Euclidean name came. So so the name of this lake is a ancient Greek mathematician Euclid. So we simply we use Euclidean plane. I hope you get it. So I just want you to explore it in Google, so that you can get what are Euclidean planes and how we find it. I can do a graph over here. So I hope you do that. So the circle continues having a coordinate. So what is coordinate? Like x1 y1 x2 y2. There are 2 points, like there are 2 points, right? So the angles in the radius. So angles, this is radius and we have angles, right? It may be angle. So this is 180 degrees. If it is G circle, then it will become 360. This is 90. So we have angles, right? So the angles in degrees. So we have a 270 degrees, 90 degrees, 360 degrees, etc. I hope you getting it. So to remember unit circle, so we have a big circle over here. So you just Google it and you're going to get the unit circle, or I can give it in a I'm going to give it in a just a few minutes. Okay, so to remember the unit circle, so we just simply take out the remainder of the 2 to all 6 functions, and which then come from the 1 to 3 and the 3 to 1, and then take root of them. So like, so I'm going to write 1 2 3, and I'm going to come reverse like 3 2 1, and I'm going to simply take the remainder of 2. So I'm going to take 1 over 2, 2 over 2, 3 over 2, and 3 over 2, 2 over 2, and 1 over 2. So I just simply write these like, right? So we just simply, and we take the root of all them. So I just simply take root of all them. I just simply take root. So just a kind of circle, just a circle kind of. So we have a circle. So just have a basic understanding of it. So we in a school days, since from our school days we have this, like we have a graph, like this, right? This is a unit circle. We have a plus plus over here, we have minus minus over here, we have minus plus here, when we have a plus minus here. So this is the x-axis and we have a y-axis. This is the origin, right? So this is a unit circle. And how we plot these points in this unit circle, and what are these relates to the unit circle. So I'm going to explain in just a minute. So to form a circle, it includes a graph. So to form a circle, it includes a graph like this, as I shown. Like, so I just want to give an explanation. So I just want to give an explanation these formulas in this circle. Okay, so we have a circle over here. So we have a plus plus over here, right? We have a plus plus, so the all values are positive. We have a minus plus over here, right? So the values become minus 1 by 2 and the root 3 by 2, minus root 2 by 2 and root 2 by 2, and we have minus 3 by 2 and 1 by 2. I hope you're getting it. So, and we have a minus minus. So this is your work, to this, and we have a plus minus here. This is these two are your work. Just simply like we have minus minus, right? So it will become minus 1 by 2 minus root 3 by 2. It will become minus root 2 by 2 and minus root 2 by 2. We have a minus root 3 by 2 and minus 1 by 2, right? So it's just simple. I hope you do that. So I hope you do that. So I hope you do that. So I just want to give like the graphs. So like, what are the graphs? So the graph is the graph of a sine, cosine. So the graph look like this. The sine graph look like this, and the cosecant graph look like this. The cosecant graph look this. So look like these are these are not perfect, right? These are not perfect, but it's similar to this kind of stuff. Okay, so I just wanted you to try out the tan, or just google it, you're going to get. So it just it's good to know like how the graphs are, and how these lines are passing through the horizon. So I hope you do that. So I hope you enjoy this lecture. So until then, bye bye, see you in the next lecture.